All right, I'm going to break this up into two parts so it's not an excruciatingly long video. But let's take a look at these first two questions. If I got a 50.6 gram sample of magnesium hydroxide, I'm going to react it with 45.0 grams of HCl. According to this balanced chemical equation, what's the theoretical yield of magnesium chloride? And what are the limiting and excess reagents? So there's already part of the problem that's giving you a clue that it's a limiting reagent problem. But if you weren't asked the question, what is the limiting reagent? How would you know that it's a limiting reagent problem? Well, take a look. We've got the mass of two reactants given and told that you're going to react them together. So whenever this is the case, you know that it's a limiting reagent problem because one of them is going to run out first. The word that we use to indicate that it's not a limiting reagent problem in these stoichiometry problems is the word excess. We say that we react something in excess. Okay, so the idea behind a limiting reagent problem is that you want to calculate the maximum yield for both reagents. And then you're going to examine it, and the smaller value of those two calculated yields will be your theoretical yield. So again, calculate the max yield for both reagents. The smallest value is the theoretical yield. Okay, so what's the plan then? We're going to still take what we're given. Now, this time we're given the two individual masses of the reagents. We want to calculate the theoretical yield of magnesium chloride in grams. And so what is the plan? We're going to have to calculate the maximum yield of both things. So that means we have to go from grams of magnesium hydroxide to grams of magnesium chloride, and we have to go from grams of HCl to grams of magnesium chloride. So we have to do stoichiometry twice. So the two full-blown plans go from magnesium hydroxide to mole of magnesium hydroxide, then to mole of magnesium chloride, and then to grams of magnesium chloride. Do the same thing with the HCl. Take grams of HCl, turn it into moles, then use the stoichiometry of the chemical equation to go moles of magnesium chloride, and then you can convert that to grams. Okay, so starting off with the magnesium hydroxide, you've got 50.6 grams of that. Molar mass of magnesium hydroxide, that's 58.3197 grams. Then the stoichiometry from the chemical equation, 1 mole of magnesium hydroxide produces 1 mole of magnesium chloride. Then the molar mass of magnesium chloride, 95.211 grams. Now let's do the same thing for the HCl, 45 grams of HCl, molar mass of HCl, 36.468 grams. Now the stoichiometry for HCl is not 1-to-1. It's 2 moles of HCl to 1 mole of magnesium chloride. And then this last step is the same because it's the molar mass as the same as before because it's the molar mass of magnesium chloride. All right, what do I get? For the first one, I get 82.6 grams of magnesium chloride. And for the bottom one, I get 58.8 grams of magnesium chloride. Okay, so what's the theoretical yield then? Remember, the general idea was to take the smaller of the two values, and that's the theoretical yield. So then again, so let's reiterate. Take the smaller of the two values, and that's the theoretical yield. What about the limiting reagent? Well, the limiting reagent is the one that controls the theoretical yield. It's the one that runs out first. So that was the HCl. And that makes the magnesium hydroxide the excess reagent. Okay, that's it for this part. I'm going to do another video for the last half.